Good morning children. We will be continuing with our next topic, importance of air. Okay, we already saw air is nothing but a mixture of gases. So we need air to survive. And then each component in the air is useful. How will it be useful? We will see. We saw what are the main components. We saw nitrogen, then we saw oxygen, then we saw carbon dioxide. Then we came across dust and smoke, everything, water vapor, all. So first major abundant gas in air is nitrogen. So how is this nitrogen useful? We want nitrogen because nitrogen is the building block for our proteins. Proteins are what? Which help us in growing. Okay, so the proteins are formed or the nitrogen is the base for the formation of proteins. So the nitrogen is essential for all forms of life on earth. We are all talking about only our planet earth. So here for all forms of life we want nitrogen. Why? Because it forms the building blocks of proteins, which is forming nitrogen, and it is required by plants for their growth. Okay, and also for animals and human beings. Now, the nitrogen in the air is converted into the usable form. Okay, which is nitrates and nitrites. And there is a series of chemical reactions like lightning and rain. So whenever there is thunder, rain, lightning, all these are chemical reactions which help us to convert the atmospheric nitrogen. Atmospheric nitrogen means the nitrogen present in the atmosphere or in the air to the usable forms. Okay, that is, say example, when it is raining, what happens? The nitrogen in the air can be converted into some water, that is will be mixing with the rainwater, and once it falls on earth it can be absorbed by the plants. The moment it is absorbed by the plants, you can make use of that. That is, you here means our human beings or our animals. All this can take or make use of the plants. Nitrogen. Okay, so that is what they say. This way nitrogen is introduced into the soil. Also, there are some bacteria or microorganisms that is present in the soil, which will help to convert the atmospheric nitrogen into usable forms. So, by all these things, the atmospheric or the gaseous nitrogen is converted to usable form. Then animals will get from nitrogen by eating the plants, and when plants and animals die, again their remains, that is the remains will get mixed with soil and they are decomposed. Okay, the process helps in returning the nitrogen to the soil. Also, the waste matter excreted by the human beings or animals will also have nitrogen. Okay, then that is like our the waste matter here is, we are talking about the urine. Okay, the urine will have a lot of ammonia content, so that ammonia will have nitrogen, and that nitrogen is again absorbed by the soil. Okay, so the nitrogen returned to the soil is converted again to gaseous form or by the denitrifying bacteria. So this will form a cycle. That is, from the atmosphere, the nitrogen is going to the soil either through rain or thunder or by the bacteria. That is the nitrogen fixing bacteria. Okay, so the plants will absorb the nitrogen. Then that nitrogen is passed on to the animals. Okay, so when animals either excrete the waste materials or if they die, okay, or decompose, the same nitrogen is again what? Going back to the soil. Okay, again from the soil it can be converted again to gaseous form, okay, by using the denitrifying bacteria. So the nitrogen cycle is complete. Okay. Now coming to the oxygen, the next major component. Okay. What is that? Oxygen. So all living things will require oxygen to live. Is it not? Without oxygen, nobody can live on this earth. Okay. So respiration. What? Respiration is a process where we take in oxygen and we give out carbon dioxide. Okay. So living things inhale oxygen. This oxygen, it will go inside and will it come out directly like that? No, it has its own work. The first work is it is going inside our body to break the food. The break the food means what? Food is inside the stomach, but we breathe air inside the lungs. Okay, that is we breathe air through our nose and it goes inside the lungs. What is happening? This oxygen will get mixed with the blood. Okay, and then this blood will go inside our stomach where it will be mixing or it will be giving the energy to the food to break down. That is to break down the food particles. Finally, there is a lot of energy obtained after the food is broken down. So, the energy needed for the organism to carry out other life processes. Other life processes means what? Like thinking, learning, running, doing all physical activities. Okay, so all these physical activities require energy. Where is this energy coming from? That is coming only because our food which we eat is broken down in the presence of oxygen. Okay, when certain reactions happen in presence of oxygen, that is called combustion. Okay, so those reactions will give out heat and lot of energy, and that energy is what we human beings and animals require for living on earth. So this is the definition for respiration. The process of burning or breaking down of the food in the presence of oxygen to produce energy is known as respiration. Okay, so the food, whatever we eat, is rich in glucose. Okay, so the glucose will mix with oxygen and then it is breaking down. What are the reactions you get? You get carbon dioxide, water vapor and energy. So this is the carbon dioxide which is going outside. When you exhale air, that is when you are giving out, that is when you take in oxygen, the next thing you will be giving out carbon dioxide. So this carbon dioxide is nothing but it is coming from this reaction. That is when the glucose in our food is being reacted or being burnt with the presence of oxygen, you will be getting carbon dioxide, water vapor and energy. Okay. Now combustion. What is this combustion? Combustion means it's a chemical process where the substance will combine with oxygen to produce new substance and release energy in the form of heat and light. So any substance that is burned in air to give heat and light is called fuel. That substance is called fuel. So the fuel will burn, that is will mix with oxygen. Okay. That is why burning. Burning means oxygen and heat together is called burning. Will give you carbon dioxide, water vapor and energy. The same equation is here. Same equation. Here we are not giving explicit heat. That is we are not burning ourselves. Burning here is our body temperature only. Okay, so that temperature is enough. Here burning is we are going to light or we are going to put fire. Okay, for the substance. So substance is the fuel. So fuel plus oxygen will give you carbon dioxide plus water vapor plus energy. This energy is the energy which will be used for cooking the food or to run the automobiles or to produce energy in industries. So what are the types of fuels you have? Solid fuels, liquid fuels and the gaseous fuels. Solid fuels, wood and coal. Wood is what? The dry trees, dry plants or all these things will become wood, which is used for cooking purposes. Coal, that is a fossil fuel which is formed thousands of years ago, that is after the decaying. It will be obtained after the decaying of many plants and animals over millions of years. So carbon plus oxygen will give carbon dioxide. Okay, and this coal is used for mainly in producing electricity. Then coming to liquid fuels, you have petroleum fuels. Petroleum fuels, you should remember petrol first thing, the next one is the diesel and the third one is the kerosene. And then coming to the gaseous fuels. Gaseous fuels, liquefied petroleum gas, that is LPG, and the compressed natural gas, CNG. LPG is the one which we all use in our homes in the form of our cylinders, gas cylinders, is it not, which we use for cooking. Okay, so that is the LPG, liquefied petroleum gas. Okay, now coming to the CNG, compressed natural gas. This is also used as fuel mainly in automobiles because it is a cleaner fuel. Cleaner means it is not releasing so much of pollutants into the air. Okay, so children, go through these two topics, that is only nitrogen and oxygen, the importance of nitrogen and oxygen thoroughly, and let me know if you have any doubts. Okay, thank you.